Another thing that you definitely need to know about ellipse, maybe it doesn't sound that important to you. In nature, the ellipse is even more fundamental than the circles. If so far in geometry, you've been liking the triangles, right, the circles, the squares, the rectangles, right, because they're easy to deal with, or the reason why people like the circles is it's the simplest symmetric trivial shape, non-trivial shape, right? Because there are a lot to talk about the circles. But ellipse, do you see that it's pretty much like a circle getting stretched, right? Either horizontally or vertically. And later on, we will refer to ellipse like this, a horizontal ellipse or vertical ellipse. And also you see that now I don't know if it's a good idea to call it that way, but to me, the ellipse seems like a round rectangle. It has length and a width. And there's a reason why I like to think of that way. Do you guys know that for a rectangle with length and a width, the area of the rectangle will be length times width, right? What if you have the ellipse with the same length and a width? So I'm not going to ask you to guess what the area will be for an ellipse like that. And I'll show you. And you'll see that, surprisingly, this does have something to do with just like the rectangle. Right? It's pi over 4 length times width. Okay. Yeah, Zach. Say it again. Exactly. Yeah. But I write it that way so that you can see, oh, isn't that the area of a rectangle? I mean, if I were to make a rectangle, it has a bigger area, right? So now, how do I see that this guy does have a small area that's the corresponding rectangle? Pi over 4. How much is pi? Over 4, that's less than 1. So therefore, the ellipse does have a little bit smaller area, right? But do you see that? I mean, if you just want to visualize the ellipse, length and width. And it turns out that you need the length and width to draw the ellipse. And let's do that. Oh, almost forgot to mention probably the most important thing. How do we define the ellipse in geometry? So just to make the process a little bit straightforward. So now here's a real world situation. So you see that maybe you have some elliptical path going on. So these are the 2 points I specify in a space, f(1), f(2), and turns out that they are called focus. Right, so or like a foci since there are 2 of them, or foci. So let's say the first focus could be your home, and this is the school. So you're usually going to travel back and forth, right? Let's say you get up class, right, at 3, then you're going to go home. But let's say if you decide to visit some place after school, almost every day, right? You're going to go to Costco, do some shopping, you're going to visit Starbucks, get a drink, right? Or you want to study at your friend's house. But let's say you ride a electrical scooter that has a limited mileage, let's say 10 miles. So you want to see that how far can you get after school on your way home. Let's say you start from the school, you visit your friend's house, right? But now you have to make sure that you still have some mileage to make it home, right? So let's say, I could say 10 miles. That's the most you can get out of the scooter. So you visit your friend's house as far as you can go. You visit a grocery store, and again, try to make it as far as you can within the mileage, right? And it turns out that the distance from the farthest place you can visit on your way home, away from the school and home, added to be 10. It better added to be 10 or less, right? Otherwise, you run out of mileage, So let's say you wait for like a month or a couple months. You're gonna track maybe in a Google map to see where you have been after school and plot your trajectory. See that, oh, you're here, right, on day one, somewhere else, right? And the trajectory of the point will be an ellipse. And here's where you can see it. So I measured the distance from a random point in the space to F1, F2, right? And the distance from P to F1 is the little f, and the other distance P to F2 is the little g. And however they change, they always add up to be within acceptable, error, the range of error. They add up to be 10. And as you can see that the trajectory of the point P is ellipse. Okay. All right. Say it again. D stands for the total distance, which is the sum of the distance from P to F1 plus P to F2. So they add it to be like the total mileage you're allowed to have, right? And that is the definition of the ellipse. Any point in a space whose distance away from two reference points add up to be a constant. And you can specify what that constant is. Okay. You can also choose what the two references. Okay. And also in nature, you know what? For some reason that those references, those constants was picked for us. Anyone know that the trajectory of Earth or any planets in the solar system is not going around the sun in a circular path. It's elliptical. And the sun is at one of the foci. Naturally, right? There's something magical going on with the geometry. But the problem is, you see the math, it doesn't seem that magical anymore. Let me stop that. In order to specify what that point P is supposed to be, if I zoom in, do you see how complicated the equation of the coordinates of P has to satisfy? But don't freak out. Just take a close look at these two radicals. Does it remind you anything? Okay, so yeah, the circle formula, right? Or you know what's better than the circle formula, because it actually came from a much more fundamental measurement in geometry, which is the 2-point distance. So take a look at f sub 1. What do you think will be the coordinates of f sub 1? Positive 4, comma 0, right? How would I find the distance from a random point P, which is located at x, comma y, to the point f sub 1? Don't I simply subtract their coordinates? Here, right? X minus 4 square plus y minus 0 square, take it to square root. So the first radical is the distance between the P and F1. What about the second radical? Well, there is another focus. F2, right? But F2 is located at negative 4, comma 0. Subtract the coordinates between P and F2, you get the second radical, which works out as a distance between the P and F2, add up to be 10. Do you see that? By specifying these 2 points and the total distance that I want, put them in algebraic form, and whatever points P have the x and y coordinates that satisfy the equation must be on ellipse. And it did. If I were to plot the equation, it's a perfect ellipse. Okay. But now, unfortunately, the equation like that, easy to get, right? Because you don't have to learn anything new. You just have to remember that the distance added to be a constant, right? The distance from a point to 2 references, but it's so hard to use, right? So in this case, this ellipse has, if I asked you to read off the length and the width, so I don't know if it's big enough to see. It extends to negative 5. It's kind of too small. Negative 5 to positive 5. So the length is 10, right? The width, it goes from negative 3 to positive 3. The width is positive 6. There's a much easier way to specify the equation instead of doing all those radicals, right? So let's do that. So I'm going to type up an equation that goes like this. It's quadratic, unfortunately. X squared over half the length. In this case, it's 10, right? Take the half, so it'll be 5, right? Half the length of the ellipse squared. Plus, so again, y squared. You probably haven't seen, equations that has y squared at the same time. So now you do. Then half the width squared. Half the width is 3, right? Square. And add them up and set it to 1. It's going to work out as the same exact ellipse. Now, instead of plotting that ugly equation, the better one will give you the same exact equation. And guess what we're going to call that easier form? Is the standard form of ellipse. That's what you need to get used to using. The one that we use to build it, we do some algebra to prove to you that we can end up getting this guy. You guys remember that the standard form of the equation of a circle back in the fall? X minus h squared plus y minus k squared, right? Added to be the r squared. It's just like that. Not to mention the circle can be shifted, right? You have to, complete a square to get the equations. You're going to do all of that, but with a new geometry. That's what you're getting from 10.1 plus 10.2, 10.3, okay?